开始了。你开始录吗？
开始了。
哦，好，那计10分钟啊。So today we're going to talk about the voice investigation, and will be my and this I'm going to talk about how we use a paper con or other materials con to produce a louder voice, and we're going to invest what kind of parameters and why it will cause a better effect. So this will be my outline of today's presentation. First I'll be starting by topic introduction and then ask some crucial questions. After that, I'll show my experience and also compare it to the theory and literature review. So to start with, loud voice asks us to use a simple cone-shaped or horn-shaped object and to optimize the transfer of human voice to remote listener. And we're going to investigate how the resulting acoustic output depends on relevant parameters such as shape, size, and materials of a cone. And here are some crucial questions I would like to ask, including how to make a funnel that boosts the volume of the voice, and try to achieve the maximum gain through different shapes, size, and materials of a funnel, and explain why one works better and the others works worse. And also, how is the volume left, right, above, or below of the cone will affect my measuring. And also, to measure the volume at a point of a few meters in front of the funnel as we speak it from behind. And we're going to compare it, one with the funnel and one without the funnel. So this is how our experiment is done. So including, first we're going to manipulate the cost of materials of a cone. So our materials include tracing paper, which is really thin, and the different thickness of craft paper, Sika paper, non-woven cloth, plastic plate, and even foam board. And after to see which materials work the best, we manipulate the cost of the shape of the cone. And we use some simulation to do this kind of work. And thirdly, we'll also manipulate the cost of size of the cone, which is to make a cone larger or smaller. And finally, which most importantly, we're going to measure the volume of different places of the cone, and we're going to investigate the data. We also had to do one of the experiments, and that is to put the acoustic wavefront further from the cone. So, and we're also going to scrutinize the data further. And this is my setting. I'll use a frequency generator to put it behind a speaking cone, a paper cone, and then there's a 30-meter range to reach the sound level sensor. And the distance of paper cone and the sound level sensor is variable. And this is one of my results of using materials. So based on this chart, you can see clearly that in different frequencies, the thick paper cone always works the best, and the cloth works the worst. So basically from this we can find out that the thicker the material is, it might produce a louder voice than it was. And we also had compared it with the initial data of one without the paper cone. So by this chart you can also see that information. That is, without the paper cone, the sound couldn't boost. Even the cloth, the paper cone, the cone made of cloth could boost the sound better than one without the paper cone. And next, you can see this chart. This chart is all about measuring the sound in different places. So since we already know that the thick paper cone works the best, so we use that as a material to make a specific shape of the cone and measure it from different places. So by this chart you can see a very clear trend that if you measure it from the middle of the cone, it will have a lot bigger voice. But as you move further, the sound will decay, however. So this will be quite different from our simulation that I'm going to show you later on. And thirdly, in putting it in different places, we can also form a chart that shows us which is a place that has energy that generates from the frequency generator and boosts it with the paper con. So the picture will be shown right here. So you can see basically it is a middle that has a larger voice. However, if we measure the sound from the inside of the con, however, that wasn't where this sound has a bigger voice. So we believe that's because some of the sound fractions and diffusion that will cause why all the energy will kind of converge in a specific spot that is further away of the con. So we also find out that where can we find the best place to which has a higher which has a louder voice of this con. And this is all my experiment. We're going to compare it with my simulation and the literature review. So by the simulation, you see clearly that since the sound only decay in the simulation, so basically it is quite different from our result. However, one thing is still the same, and that is first the sound will boost, and secondly, after the sound generates and transfers through the con, it was places that the sound started to boost. So also, the bigger the con is, the louder the voice it will generate. And this is my simulation, just show a few simulations. And now we're going to go to literature review. Compared to the Gabriel's horn formula, we can know the best shape of a con which could boost the sound best is a con shape like this. So you can see from this simulation, you can see the radius and also the curvature of the con. So, however, we have the difficulties to make this one by a paper. So we're going to further use a 3D printer to print this with some thick plastic plates. So, and we're going to make sure that it does work the best. And this is another our Gabriel's horn, which has a special curvature shown like this formula right here. And then, and as other sound generators, it boosts the sound like this. So basically, the frequency generator generates the sound of plane wave, comes throughout the con, and then the wave has some refractions and also some reflections inside the con. And all these, it will tend to emerge a certain few spots, and that kind of spot called hot spot, which we can measure the loudest voice of the sound that generates from the frequency generator. So also the chart will be shown right here. And furthermore, if we scrutinize into the matter of the Gabriel's horn to see it perpendicularly, we can see it, the curvature shown on the chart, and we use a coordinator to address it, and you can see every certain spot how the sound would boosting. And if we go furthermore, which is after the sound leaves the Gabriel's horn and starting to decay in the real world, and the energy of the voice will show right here. And thus we're going to have some conclusion and future aspects. So we believe that to use the loud voice, we first believe is something that really easy to do. However, it includes many complicated formulas and some concepts that we're still working really hard to understand. However, by all these experiments and also these things that we go through, we believe that first we know what kind of materials will work the best of the loud voice of the con, and secondly, it's not every spot of the con that we can hear the loudest voice. In only the certain spots we can get louder voice. And not only the shape of the con, the materials of con affects. It was also the size of the shape effect too. because as it is become bigger, we simulate it and find out since it was bigger, so the sound will be more focused into the horn, and when it when it passes out from the Gabriel's horn, it will have a bigger effect. So 无声道. So this is basically a conclusion and future aspect, and thank you for your kind attention.
好。